all of you are doing good. Let's start today's chapter, number system. Natural numbers. In our daily life, for counting objects, we use the numbers like 1, 2, 3, etc. These numbers are called natural numbers or counting numbers. Natural numbers are represented by the digit 1, 2, 3, 4, 5, 6, 7, 8, 9. These digits used in the Indo-Arabic system are called digits. Since the process of counting is endless, there is no largest natural number. However, as we begin counting with 1, so the smallest natural number is 1. So we shall define some terms often used in number system. Number 1, digits. The symbols 0, 1, 2, 4, 5, 6, 7, 8 and 9 used in numbers are called digits or figures. Numeral. A group of digits denoting a number is called a numeral. Normally, we use the terms number and numeral as the same thing. Notation. The method of representing a number in digits or figures is called notation. And numeration. The method of expressing a number in words is called numeration. Further, we have seen that natural numbers are of two types. Number 1, even numbers. The numbers which are multiples of 2 or are called even numbers. For example, 2, 4, 6, 8 and so on. Number 2, odd numbers. The numbers which are not multiples of 2 and are called odd numbers. For example, 1, 3, 5, 7. Okay. Next, whole numbers. The number 0 together with the natural numbers or counting numbers gives us a set of whole numbers. Clearly, every natural number is a whole number and 0 is the only whole number that is not a natural number. Or in short, we can say that whole number starts from 0 whereas natural number starts from 1. Okay. Now, reading and writing of numbers. There are two methods of numeration. They are number 1, Indian system of numeration, and number 2, international system of numeration. Indian system of numeration. In this system, we use the following place value chart. Okay, see, this is Indian system. Ones period, thousands periods, lakhs periods and crores. Now, after crores, it's Arab, Arabs and 10 Arabs. Okay. So, in this system, a given number is split into groups or periods. Starting from the right backwards, the periods are called ones, means this one. Thousands, lakhs, crores and Arabs. The ones are further split into units, tens and hundreds. The thousands periods further divided into thousands and 10,000s. And in similar manner, rest of the periods are divided into 2. In the Indian system, the numbers are written using the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, with each digit getting a value depending on the place it occupies. Let us consider some examples. Example 1. The number 5,32,891 represents a collection of 5,32,800s, 9 tenths and 1 unit. It can be written as, okay. So, in the expanded form, the expanded form of this number is this, which you already know how to write in the expanded form of, okay. Example 2, consider this number. How do we read this? 3 crore 25 lakh 3,125, okay, and expanded form of this number is this, okay. Next, place value and face value. A digit in a numeral has two values, a face value and a place value. Face value, the face value of a digit at different places is the digit itself. Thus, the face value of a digit does not depend on the position it occupies in the number, okay. Next, place value. The place value of a digit depends on its position, right? Remember that. Though I know that you already know how what is place value and what is face value, okay. So, the place value of a digit depends on its position. It is a value of a digit acquired by the value of its position. Thus, in this numeral, that is 83,258, the face value of both 8s are 8, whereas the place values are 80,008, okay. Now, let us consider a numeral. So, 4 has the place value of 4 into 1 because it is at units place or ones place. 5 has a place value of 50 because it is at tens place. 6 has a place value 6 into 100, that is 600 because it is at 100 place. 7 has a place value of 7,000. 8 has a place value of 10,000. So, from the above we know the following. Number 1, a number is the sum of the place values of all its digits. Number 2, place value of a digit is equals to place value into face value. Okay, and number 3, the place value of 0 is 0 wherever it may be. Okay, no matter at which place is 0, its value gonna remain 0 always. Okay, place value. Next, international system of numeration. It is the system of numeration followed by most of the countries of the world. In the system too, a number is split into groups or periods. In the system, the groups are called ones, thousands, millions, billions and trillions. The ones are split into units, tens and hundreds. The place value chart in the international system is given on the next page. See, ones period, then thousands period, millions period, and then there is billions period, and after billions period there is trillion period. Okay, so in the international system too, numbers are written using digits 0 to 9, with each digit getting a value depending on the place it occupies. For example, in the above chart, 78,421,739,902 represents a collection of 7, 10 billions, 8 billions, 421 millions, 739,902 units. And the number written in the chart is this, and this is its expanded form. So, as in the Indian system of numeration, in a place, if a place is vacant, we indicate it by putting a 0 in that place. However, no 0 is put at the extreme left of a number. Okay. Next, reading numbers. For reading numbers, we group place values into periods of ones, thousands, millions, billions and trillions. The first 3 digits from the right of a number make units period. The next 3 make thousands period. The next 3 as million period. The next 3 billion periods, and the next 3 trillions period. So the digits in the same period are read together, and the name of the period is read along with them except units. Now let us consider an example. Consider this number. It is read as 7,832,451,324. Comparison of Indian and international place value charts. As we compare both systems, we observe that 1 lakh is equals to 100,000. 10 lakh is equals to 1 million. For example, if a person has 1 million subscriber, that means it has 10 lakh subscribers. Okay, and 1 crore means 10 million. Okay, 10 crores means 100 millions, and 100 crores means 1 billion. In both systems of numeration, numbers are written in terms of ones. That is 10 raised to the power 0 is equals to 1. 10 raised to the power 1, tens, hundreds, that is 10 raised to the power 2, thousands, that is 10 raised to the power 3, and so on. These systems are known as decimal system or base 10 system. Okay. Example 1. Determine the difference between the place values of 2 nines in this number. Okay. Now considering the digits from the right, 9 is in the third place. Okay, as you can see here. Okay, right, this 3, 9, 8, 5, 6, 9, 2, 1. Okay, place value of this 9 is 900 because this is at 100 place, and place value of this 9 is how much? You will add 6 zeros. Okay, 90 lakh because it is at lakhs of place. Okay, now we have to find the difference between these two place value. Let's subtract. Okay, you will subtract this from this. Minus 900. So what will you get? You will get this number. Okay. Exercise 1.1. Write the numeral of the following. 88,410. Okay. Next, successor and predecessor of a whole number. Successor of a whole number. If we add 1 to any given number, we get the next whole number, which is called its successor. Thus, a number 1 more than a given number is called its successor. The successor of 10 is 11. Successor of 25,678 is 25,679, etc. As we know, every whole number or natural number has its successor. So there is no end to this sequence of whole numbers. Predecessor of a whole number, 1 less than any given whole number except 0 is called its predecessor. The predecessor of 1 is what? 0, obviously 0 comes before 1. The predecessor of 31,209 is 31,200 and so on. Each whole number has only one predecessor, not more than that. Okay. Now let's do example. We have to find the successor and predecessor of 879. Okay. Successor and predecessor. Successor is 880 and predecessor is 878. Okay. Representation of whole numbers on a number line. We can represent whole numbers on a number line as follows. We draw a straight line and mark a point 0 on it, representing the first whole number 0. Starting from 0, we mark points A, B, C, D, etc. Such that the distance OA is equals to AB is equals to BC is equals to CD. Okay. In the figure, we observe that OA is equals to 1N. Okay. Now, OB is what? OB is equals to OA plus AB. See, this is OB and OB is what? OA plus AB. That is 1 plus 1 is equals to 2 units. Okay. OC is OA plus AB plus BC is 1 plus 1 plus 3 units. And OD is equals to OA plus AB plus BC plus CD, that is 4 units and so on. So, the points O, A, B, C, D represent whole numbers 0, 1, 2, 3 and 4 and so on. We can represent any number on the number line by some point on the number line. The arrow marks on both ends of the line indicate that the number line extends infinitely on both sides. Okay. Properties of whole numbers. The number line enlightens us regarding the properties of whole numbers, which are as follows. Property 1. 0 is the smallest whole number. We all know that, and there is no largest whole number. Okay. We observe on the number line that there is no whole number on the left of 0 and every number on its right is greater than it. Property 2. Each whole number has one and only one successor. Each whole number is a successor of the whole number on its left. However, 0 is not the successor of any whole number. For example, 8 is a successor of 7, 12 is a successor of 11, etc. Property 3. Each whole number has one and only one predecessor. Each whole number is the predecessor of the whole number just on its right in the number line. However, 0 has no predecessor. For example, 15 is the predecessor of 16, 25 is the predecessor of 26 and so on. Property 4. Every whole number on the number line is greater than every whole number on its left. For example, 15 is greater than 11 because 15 is right and 11 is left. 25 is greater than 15 because 25 is right side on the number line and 15 is left side on the number line. Okay. Property 5. Every whole number on the number line is less than every whole number on its right. For example, 12 is less than 15 obviously because 12 is to the left side of 15, right? Next, comparison of two whole numbers. The number line helps us to compare two whole numbers. When the numbers are small, we can plot them on the number line and the one on the right of the other is obviously greater than it. However, if the numbers are big, we cannot compare them with the help of number line. In such cases, we employ a rule called order property derived with the help of number line. Okay, what is order property? Of the given two different whole numbers, the smaller one is that to which we have to add a natural number to get the other one. For example, 20 is less than 27. So, 20 plus 7 is equals to 27, right? Similarly, 985 is less than 1250. That means 985 plus 265 is equals to 1250. Betweenness. The number line also displays the property of betweenness. Suppose we consider any two consecutive whole numbers, say 9 and 10. Obviously, there is no whole number between them. But if we consider two non-consecutive whole numbers, say 8 and 15, there are many whole numbers lying between them. Clearly, we can say that 8 is less than 9, 9 is less than 10, 10 is less than 12, and so on. Okay. Exercise 1.2. We have to represent the given numbers on the number line. Let's represent. Okay, this is the number line. Start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, okay, 12, 13, 14, 15. Okay, now we have to represent 3, this is 3, 5, 0, 1, 7 and 15. Okay, students, now you will do practice of the remaining questions of this exercise. Okay, learning outcomes. Natural numbers are numbers starting from 1 onwards, that is 1, 2, 3. Natural numbers are also called counting numbers. All natural numbers together with 0 are called whole numbers. The smallest natural number is 1, remember that, and the smallest whole number is obviously 0. Okay, there are two systems of numeration, Indian system, international system. The periods of Indian system of numeration are ones, thousands, lakhs, crores and arabs. 6. The periods in the international system are ones, thousands, millions, billions and trillions. Number 7. The number system we use to do all our calculations and to count is a Hindu-Arabic system. It is a decimal system. 8. Each digit in a number has a value that is dependent on its position in the number. 9. The successor of a whole number is a number 1 more than it. And the predecessor of a whole number is a number 1 less than that number. The number 0 has no predecessor. 11. There do not exist the largest natural number and the largest whole number. 12. Every natural number is a whole number, but every whole number is not a natural number. Okay, remember this line. 1 is not the successor of any natural number, and a number line is a horizontal line on which there are equally spaced points. These points represent whole numbers starting from 0. So student, I hope you have understood this chapter. Now keep practicing of this chapter.